Question 15. Given that f of x equal 1 plus e to the power of x. Question A. Sketch the graph of f of x showing the horizontal asymptote. Here, if we want to sketch any function, we'll start from the standard form of this function. Here it's exponential function, f of x equal e to the power of x. The standard form of this function is f of x equal e to the power of x. Starting from this standard form, we can graph this function by knowing the translation or the shifting or the transformation in this function. Here we can see that there is transformation, which is shifting this function or the graph of this function 1 unit up on y-axis. As we know, this function intersects y-axis at the point 0 and 1. We'll shift the graph 1 unit up on y-axis, so here we'll add 1, so the will intersect at the point 0 and 2. We can see the graph here. I used this program to draw the graph. We will see the two forms. Here we have two graphs, the red one and the blue one. The blue one is the standard form, which is f of x equal to e to the power of x. As we can see here, it's intersect y-axis at the point 0 and 1, and we shift the graph on y-axis by unit up. It will be at 0 and 2. For the standard form, the asymptote is y equal 0. Here the asymptote will be y equal 1. So the red one will be the graph of this function, which is f of x equal 1 plus e to the power of x. That's question A. Sketching the graph. Showing the horizontal asymptote, we have to draw the graph. This line. This is the horizontal asymptote. That dashed line is the horizontal asymptote. We have to show. Question B. Here you ask to find the domain and range of f of x. We said before that the domain related to values of x and range related to values of y for this function. The domain for this function is all values of r or real numbers. Here domain related to values of x and belongs to all values of real numbers, so the domain will be real numbers. The range related to values of y, so we'll say that y belongs to the set of real numbers, but starting from values bigger than 1, not equal 1. The range start from the asymptote up or from the asymptote down. The asymptote is at y equal 1. So the range will be either y bigger than 1 if the graph up, or y smaller than 1 if the graph drawn down. Question 13. Solve for x. Here it's solving equation with e power x. Solve for x. 5 multiplied by 4e to the power of x minus 3 all to the power of 3 equal 625. Solving the equation means finding the values of x which satisfy the equation. Satisfy the equation means the value of x which makes the two sides equal. Here we have to make or to write this part, which is a power x, separate on one side and all other parts or other numbers on the other side. So here we have to separate e to the power of x. First, here it's 5 multiplied by the bracket, so we'll divide by 5 divided by 5. So you will get 4e to the power of x minus 3 to the power of 3 equal 25. 125. Then we have bracket with power 3, so we'll take cubic root for both sides. And here you have to pay attention. In square root we have to put positive or negative, but in cubic root we don't have to put positive or negative. This only put it with square root, not with cubic root. So don't forget this point. If you are taking square root, you have to put positive and negative. Cubic root, we don't have to put positive or negative because it will be only one value. Here, cubic root with power 3, so you will get 4e to the power of x minus 3 equal to 5. It's similar to linear equation. We'll move plus or minus, then multiply or divide it. So we'll move negative 3 to the other side, positive 3. So it will be 4e to the power of x equal 8. This part is multiplied, which is 4. Move to the other side by dividing over 4 over 4. So you will get e to the power of x equal 2. That's what we want to get, e to the power of x in one side. As we get e to the power of x in one side, we have to take ln for both sides. If we take ln for e to the power of x, you will get x. It's mentally, because it will be x ln e and ln e equal 1, so we write e x direct. So x equal ln 2. Here you can leave the final answer in this form, x equal ln 2, or you can convert to be decimal its value 0.69315 if he asked to convert. So if he said solve for x only, you can write the final answer in any form. If he said solve for x and write or giving your answer to one decimal place, significant figure, you have to write the final answer in the asked form. Question 17. Differentiate with respect to x the function y equal e to the power of x to the power of 3 plus 1. Here it's a very direct question, it's very simple. It's differentiating exponential equation with base e. As we said before, the rule of differentiating this function is writing the same function. We have two parts multiplied. The first part is the same function, e to the power of x to the power of 3 plus 1, multiplied by the differentiation of the power. If we write the power here, x plus 3 plus 1, and we differentiate it, it will be 3x to the power of 2. So it will be 3x to the power of 2. Write this expression in order. It will be 3x to the power of 2 multiplied e to the power of x to the power of 3 plus 1. And this is the final answer. Question 18. If f of x equal x plus sine 2x, find f dash of 0. As we can see here, that here he put it between brackets x, and here he put it between brackets 0. So simply we will put, or it means we have to put 0 in the place of x. But the question is, we'll put 0 in the place of x in which expression? Here we have to pay attention in this part. We'll put 0 in the place of x in the expression of f dash in the first derivative. So this question simply means we have to put this value in the place of x in an expression and calculate. But the question is, which expression? The expression f of x, or the expression f dash of x, which is the first derivative, or the expression f double dash of x, the second derivative, or the expression f power negative 1 of x, which is the inverse. So we'll put the value in the place of x. In which expression? We have to mention this expression. If the expression exists, so we'll put the value direct and calculate. If it's not exist, we have to find. Here he gives f of x, and we have to put 0 in the place of x in the expression of f dash in the first derivative. Do we have the expression of the first derivative? No, so we have to find. F of x equal x plus sine 2x, so f dash of x equal, here as we can see, it's two parts. The first part is x, which is polynomial, and the second part is sine 2x, which is trigonometric. We'll differentiate each part separate, as we said before, between plus or minus, each part separate. The differentiation of x equal 1. Differentiation of trigonometric function will be two parts multiplied by each other. The first part will be the differentiation of the trigonometric function. Here the function is sine. The differentiation of sine is cosine for the same angle, multiplied by the differentiation of the angle. Differentiation of the angle 2x is 2. So remember, differentiation of trigonometric function, two parts multiplied by each other. The first part, differentiation of the function sine, cosine, tan, sec, cosec, cotan for the same angle, multiplied by differentiation of this angle. So we can write, here we finished differentiation, but we can write it in ordered form. It will be 2 cosine 2x. To find f dash of 0, simply we have to put 0 in the place of x and calculate. Cosine 2 multiply 0. Using calculator, you will find it, it's equal 1 plus 2 equal 3, and this is the final answer. So the most important point in a question like this is to mention we have to put or to substitute with this value in the place of x in which expression. If the expression already exists, we have to substitute direct. Not exist, we have to find.